I'm currently CTO at a company called Statflow. And what we do is basically use data to drive a set of tools to make wireless customer service suck a lot less. So everyone hates dealing with their wireless carriers. We build products to make that a little bit better. And in my free time, I play a lot of Frisbee. Any Frisbee fans in the audience? All right. Wow, super popular. Great. So I'll be in the speaker's corner to teach you guys about Ultimate Frisbee later. If you can't tell from this slide, that's somebody mopping in the rain, which is sort of an illustration of futility, how it's valuable to you, why it's worthwhile. Basically, Docker itself is gigantic. How many people in the audience are using Docker right now? Cool. How many people are using Docker in production right now? Cool. Okay. So I don't want to make Docker seem hard and complicated. I just want to sort of illustrate my experience, our company's experience using Docker and how we utilize it and how it all comes together. And sometimes it's difficult to figure out what Docker looks like in a typical company or in a startup, because there's so many moving pieces. The ecosystem is enormous. So I'm going to just sort of illustrate this in a simple way, if I can. So why pipelines? So why do I like to think in pipelines? Why do I think it's valuable to think in terms of pipelines? It's really valuable to think in terms of iteration, right? We always want to do things as often as we can and as many times as we can, right? Because if we can do things 100 times a day, we are probably pretty good at it, right? I used to, when I started out doing automation and build engineering, I was working for a company that was shipping physical CDs. So we would burn CD-ROMs, put them in a package with a binder manual, which we printed out in the office, and with 3-hole punch stuff, put it in the binder, and then put it in an envelope and put it in a mailbox. And that was shipping software. And that used to take a week. And so we would release once a month, and a week out of that month would be putting this all together, sending it out to all our different clients. Industry standard for a delivery pipeline is about 10 minutes. You kind of want from code to production to be about 10 minutes. And that's what we aim for inside of Statflow. So I mentioned that the main reason that we want to ship is that if you're doing something that often, it's going to be very apparent what sucks and what's not working well and what's causing problems. And you're not going to be under the gun at the last day or the last hour of the last day before you have to ship something to find out that your process is broken. And you've got to go look at how to build the thing that you were supposed to ship 20 minutes ago, right? If you're doing that 100 times a day, you know hours and hours before you've got to do it for real that it's going to work. And you have a high degree of confidence that it's going to work. So if you're doing it often enough, it's probably automatable, it's probably repeatable, it's probably standardized, it's probably consistent, right? And that's what we want in software, because we want to be worrying about complicated things, not the stuff that we do over and over again, right? You want to be worrying about the new thing. In terms of continuous delivery, and value and providing value to a business, there's parallels to manufacturing, because of a lot of old school product manufacturing, building cars and whatnot, is based on pipelines and automation and looking at things in terms of a value stream. How many people have heard the term value stream mapping in the audience? A few? Okay. Anyone who's interested in sort of process and automation, I recommend looking into there's a book called Learning to See, and it's all about sort of evaluating processes to find points of automation, points of efficiency, ways to sort of optimize. And it's really valuable to sort of think of things in terms of a start to finish in a repeatable process to improve your end goal by optimizing a process. things suck less when we repeat them over and over again, right? Because it becomes really tedious to deal with failure over and over, and you tend to get rid of it. So back to the concept of the pipeline, it's going to vary in every company, it's going to vary in every team, it's going to vary in every product. You don't have the same dependencies, you don't have the same number of steps involved, you don't have the same number of moving pieces, and so this is my experience with a very specific product inside of our ecosystem, but the large majority of moving pieces can apply to almost anything. So when we talk about a pipeline, what is a pipeline made up of? It's made up of a start and an end point. It has to have a clear start and it has to have a clear end, or else you really don't know what you're dealing with, and you don't know what to expect. You don't know your inputs, you don't know your outputs. So in software engineering, it starts with source control. It probably starts with a change that's committed to a source code repository and pushed to a centralized management system. You want to run it every time there's a change. You want to be able to parallelize it, so to make it more efficient, you want to be able to split up things that don't need to be sequential for efficiency, so that you can run multiple operations at the same time and save time. And you measure it by successfully deploying a change into production, right? You see a change, or there's a concrete change in the ecosystem. So continuous delivery: change, validate, stabilize, and release. So you want to be deploying a change in a way that you can measure whether or not that change is successful, right? You want to make sure that it's not going to behave differently than you expect the moment you let it out into the wild, right? So there's a lot of quality assurance and testing involved in making sure that it's not going to go crazy as the moment that it hits your production servers. So in very abstract terms, this looks like code change, testing, building an artifact, deploying that artifact, and then running it, right? And in the Docker ecosystem, this becomes very concrete as, the artifact is the container. But the artifact could be a jar file or a zip file. It really doesn't matter. So what you want to do is sort of progressing through this evolution where you're going towards a more mature pipeline. You start with deploying directly to a server, right? Then we have continuous integration where we were testing sort of locally, right? Or in a centralized manner where we could look at our code as it relates to everything else that's going on, and as it relates to like our previous standards, right? So you could do static analysis and all kinds of testing. And continuous delivery is the process of basically merging to your previous state, right? Merging to master, and counting on the fact that you're not breaking anything. So you want to be testing your code mixed with master to make sure that nothing is broken, and you have a high degree of confidence that you can deploy that when you want in a safe manner. Continuous deployment is basically crossing your fingers again, but we've gone through all these other previous steps to increase our confidence. So a pipeline is really important, not just for the automation standpoint and not just for optimizing process. It's really important in sort of collaboration, right? And working within a company. So what do I mean by that? So this is, you can imagine this gentleman as Donald Trump, I guess, is in current events. You want to be able to release your software and not screw up anyone else's life, right? Everyone knows that sort of the origin of DevOps is that people would package up code and throw it at the ops team and say, go run this. I don't care what it takes. And honestly, I don't want to hear from you. Just make sure that it runs, right? And obviously that doesn't work. You've got separate incentives. You've got different motivations for development and operations, and you have to unify them in order to be productive, right? You can't have things hit a stop when they hit the ops team. You can't have things being thrown back to development because they're not documented properly, or something's missing. So a pipeline really acts as sort of like a door in this wall that allows information to pass back and forth and allows for a process to sort of unify the both sides. And you build sort of a clear picture for everybody of here's what it looks like. So let's talk about Docker in this context. Docker is advantageous in the context of a pipeline because you have a single unit of an artifact, a piece of operational code that can progress through this pipeline as a consistent object, and you basically know what you're getting from when you're in development to when you're in production, in concept. In reality, it doesn't always work that way. It can be screwed up by any number of dumb processes along the way, but in theory, it's very possible to deliver a consistent set of changes through a pipeline into production using Docker. It's not simple. I mean, there's a lot of overhead involved. It's not, you don't just have Docker and nothing else. You need logging, monitoring, configuration management, all that stuff that you've always had. You just have this nice little package that runs really nicely on a laptop and runs really nicely in production. But there's a lot of things that go into that. So I'll cover a little bit of that as we progress. So caveats in the Docker world. Docker is always changing. So what's true this week may not be true next week. It may not be true 6 months from now. Historically, it's been pretty volatile, but it hasn't been awful. It's a constantly evolving ecosystem. So don't worry too much about this. It doesn't really matter. It's just to sort of illustrate that there's a lot of options for everything, right? That can be very, very confusing. I don't recommend sort of diving headfirst into this. When you're thinking of sort of using Docker, it's great to sort of pick a stack, examine what it looks like in terms of the social ecosystem, like how many people are using it, how many people are talking about it, what kind of information can you glean without using it, and then take it for a spin. But, you know, take this with a grain of salt. And there's a lot of time you can waste here. So it's good to sort of pick something that works for your use case. Don't worry about whether it's the greatest thing in the universe. Use it, find the boundaries, and then, you know, move to something else if it's not working out for you. But a lot of these are becoming fairly evolved these days, and the ecosystem's fairly strong. You can use a lot of these tools interchangeably and with minimal effort, because a lot of them will run on, you know, very simple and common conventions like YAML files that translate pretty simply from one to the next. You can adapt, and for greenfield projects, you could try out something else. Just don't get caught like trying to change everything all the time. So advantages of Docker, like I would say that the previous slide is an advantage and a disadvantage. So it's lightweight, it's reusable, it uses you know, hashing and version control very well. It's very portable. You can push and pull images so you can move them around very easily. There's a lot of great features that come with using containerization. But I really want to get into this whole pipeline thing. So I think what you want to sort of think about when you're building and deploying Docker is that you want to run your unit tests locally, right? You want to run the smallest instances of your tests locally so that they're fast and you can fail quickly without waiting, you know, an hour to find out that your code's broken. Run the bulk of your tests to increase your confidence at a local level. Then eventually, you know, you want to pull from a centralized repository and just run your container, right? That way, you don't have to worry about complicated run commands or dependencies, right? You can just fire up a container and hopefully it's isolated enough that it doesn't require a million things to get it running. So you're going to want to think about, and this is where it gets a little complicated, provisioning and configuration. So You're going to need local development environments. Luckily, this is much easier these days with things like Docker for Mac and Docker for Windows. Thank God. How many people have been using Docker before boot to Docker even existed? Yeah, rough, terrible times. So luckily, there's Docker for Mac and Docker for Windows these days, and if you just gave up and moved to Linux, then you've had that benefit for a long time. But it's much simpler now to spin up local development environments and then also shared environments. So using Docker Machine, you can spin up an AWS instance that will run your container exactly how it would run on your local machine. And you can push that all the way through to production, right? Production could also be a Docker Swarm or Kubernetes, which adds a little bit of complexity. There's a lot of things that it still doesn't help you with, right? You still need CDNs, you still need DNS, you still need service discovery and all this. But in terms of the artifact, it helps a lot. So yeah, outside the container, you've still got a lot going on. And I want to sort of cover a couple of conventions in terms of containers, because it helps to think of a pipeline in terms of a gradually simplified container artifact. And what I mean from that is the container that you run in development shouldn't actually be the container that you run in production, but it should be a subset. It should get gradually simpler. Let's say that you're a full stack developer. You need to be compiling JavaScript and CSS all the time. You need to be mounting in your local folders and your file system so that you can be seeing your local changes in real time, right? There's a lot of dependencies that go on there. You're probably running Node and Ruby in the same container, and that's going to be a nightmare in production, right? You don't want all that crap sitting around with all those vulnerabilities just waiting to be taken advantage of. So it's beneficial to sort of think of the convention of a build container, and I'll get into that a little bit more. But essentially, you don't want to have all of your build requirements active and running in production because they're just sitting around doing nothing, and they're just vulnerabilities. Another big important thing is the concept of volume containers. You want your file storage, if you need it, your volume container likely lives on a different life cycle than your app container, just because your app container is going to change constantly, and you don't want to be pushing and pulling files from block storage or some other mechanism, pulling them down from S3 every time you want to run your app, right? It's ideal to have a app container pick up from where the previous instance of an app container left off, right? Kill off the old one, bring up the new one, share the same file system. You're exactly where you need to be quickly. And so the run container is the absolute bare bones, smallest attack surface that you could possibly run in production, the absolute minimum number of requirements, and the most stable version of the OS that you can possibly run. So I want to talk about the build container really quickly. This is the one where you're compiling code, you're doing all of your sort of asset compilation together. And the run, again, is just the build container executed as a run command. So you use a build container to build your run container, and then your run container is just that stripped down version of the OS. And the purpose of this is you just want to cascade your changes so that you have the simplified version running in production. So another big piece of the pipeline is QA, right? Because you want to make sure that by the time you get to this run container, this production image, it's as efficient and stable as possible, right? So this is where you sort of add some complexity in sort of to the pipeline so that you're not just pushing changes, you're actually verifying them and testing them as you go. So the standard sort of pieces of this, code commit, test environment, production, you want to be deploying to something like production before you do it in production, just so that you're not just live out of nowhere. These are all various testing stages that will happen between your stages of your pipeline. I'll share my slides so you guys can go through all these, but there's actually way more than this. There's tons and tons and tons of different tests you can do, but these are some of the more well-known ones. So most of your QA tools like Jenkins or CloudBees or TeamCity or anything will show you your build stages in terms of a pipeline, just so you can visualize it and keep track of things as that progresses. You got a lot of options, right? When you think of CI, I'm sure everybody knows these. You can pick one or any. It really doesn't matter. They all have pretty much the same functionality these days. And centralized CI is a great way of sort of collaborating and visualizing, centralizing your continuous integration so that it's more visible to your team, and it's also sort of offloaded onto a third party. And your simple deployment is basically you pull your image and you run it, right? You might have configuration management manage, the builds, the run environment. So if you're changing anything around service discovery or any of your peripheral services, you want to run configuration management in addition to that. So the whole shebang here, the whole process sort of looks like this. This is what our system used to look like. We previously used Google. We've since moved to Amazon, but we were using Kubernetes. So we would basically have our build container sort of push to the Docker hub, and then we would trigger a deploy on Kubernetes via Slack. That's pretty simple. Now we use Circle CI, so it's picking up the fact that there's a change to the build container or the prior test is completed, and it goes to check for the artifact and then goes and deploys it. So from here, what does it look like? You want to automate as much as you can, right? Because you can do most of that process manually. Automation, though, is something that you want to take your time with, right? Because it can very, very quickly become something like errors as a service. So be careful with what you automate before you know what you're automating. It makes sense to do an exercise like value stream mapping just so that you know exactly what goes on in your process. Convention these days is to use ChatOps for this, and what it really looks like is you interacting with a bot that has a set of capabilities around maybe running a deploy, maybe running tests, maybe checking on your infrastructure, maybe reporting on what's changed recently, and you can customize these very easily. How many people run chatbots in their company? Oh, very few. Cool. Okay. They'll sit on top of almost everything but Skype. Skype is a pain in the ass to run bots on, but hopefully that's getting better now that Microsoft. So you get to see what a deploy looks like because someone else is doing it right in front of your eyes. Someone is pulling logs right in front of your eyes. Someone's pulling metrics right in front of your eyes. And it's a way of sort of actively training a team by demonstration, by example. So I highly recommend chatbots as a way of sort of sharing information and democratizing the ability to make certain changes. And that person who's watching you deploy might not have the capability of deploying. Like, they don't have access to it. If they type the deploy command, nothing would happen. The bot would say, sorry, not today, like get a promotion. But they get to see what it's like, right? So that day or the day that they want to volunteer to do it, they know exactly what goes on. They know what to expect. And people in your sales team can see that there's a deploy happening. People in your success team can go and pull logs to see like, oh, this weird thing happened, like what could it be related to? So I just want to sort of finish off with a couple of opinions of my own. Before you sort of walk down the path of Docker, I would say, think about the ecosystem, think about the borders, right? Think about things like service discovery, secrets, your configuration management, what you do to manage your deploys in a rollback and promotion standpoint. So things like logging, monitoring, networking, health checks, scaling, cron, all goes with Docker and how easily you can deploy. It's deceptive because there's a lot of things that you now have to think about in the world of containers, in terms of containers. So I would say change as little as possible, and sort of isolate the amount of things that you're changing and make sure that they're positive changes. They improve your bottleneck. They address what's slowest in your process, in your pipeline. And some cautionary notes about DevOps in particular. Think about DevOps, if you're talking inside of your organization about DevOps, think about what it's composed of. It's not just DevOps. What it actually is agile infrastructure. It's test automation. It's continuous delivery. It's something specific. It's centralized logging, right? Talk about those things. Don't talk about DevOps because DevOps have way too many assumptions about it. So try and avoid the topic altogether and just talk about exactly what you want to do. Don't ignore security. It's always it's always a sticky subject, but you can use products like HashiCorp Vault. Paul's around. Is Paul in the room? No, Paul's probably not in the room. HashiCorp is in the house. You can actually talk to somebody about Vault. He'll be giving a talk on Terraform at some point. But minimize your open ports, your exposed ports, hide them behind proxies. All the stuff you guys know. It all pertains to Docker. It's not really simpler. It's not really more complex, but you probably have more moving pieces because you've got a bunch of containers instead of a giant monolith. And I would say, start with something small, right? Start with something right now. Look at a greenfield project. Look at a weekend project. Look at a hackathon, or just run a tutorial, right? Like try something end to end, and try and do it in the context of a delivery pipeline, right? Like try and ship your code via a CI tool. So you can use a tool called Strider CI. You can download. It's a node package, and it will run like a CI server on your local machine. You could run it in a Docker container as well and get that to sort of build your containers and deploy it to an environment, right? I'll talk a little bit about what we do. Notable in here is Convox. So Convox is, how many people have heard of Convox? Cool, okay, awesome. Convox is a very project out of Heroku guys. So this ex-Heroku team built this platform as a service on AWS that's specifically tailored for Docker. And what it does is it uses a bunch of AWS services, a lot of Lambda, Amazon API gateway, S3 for configuration, a bunch of things. So it locks you pretty tightly into AWS, but it's insanely easy to set up and get rolling. And it runs locally the exact same way that it runs in dev. And I'll take you guys a little bit through how it works for us. And I would recommend giving it a spin. It's totally open source. And you can run it entirely, as I said, you can run it locally and get a feel for how the deployment works, how secrets work, and the process. So this is a look at one of our projects building on Circle. It's pretty simple. I think this is from a while ago. But it's be containers that get cached and then pulled and run, loading something. Because when PyPy fails, which it does all the time, or the Convox website goes down, my whole build stops, right? So we've moved away from this to having everything inside of a container, and that way we have the image, we have all the requirements that we need. A lot of these other pieces are also like legacy build steps because they can now be run as containers, right? So we do our AWS ECR, which is the registry for downloading our containers because we push to AWS. And then this is the Convox part. So Convox, we switch to a specific environment. We have multiple environments. These are clusters that are multiple machines. They scale independently. They scale automatically. They look exactly the same, whether or not I spin up, prod development 1 through 20. They all will look the same, and it's very repeatable. It runs via YAML file. And then it deploys, and it will do like a rolling deploy, right? So it keeps the instance of the app that's current running. While it brings up the new one, it smoke tests the new one, and then it starts gradually redirecting traffic. And it does a health check while it runs. So this is sort of like the end-to-end of a common deploy that we do using CI, and it sort of matches this pipeline metaphor where everything is just a sequential build step. You start with code, you end with a container in production, and you have a very high degree of confidence that what you're running in production has been tested and tried in a separate environment, and validated several times. And I think that's it for me. So part of the reason that I'm here is not just to speak at the conference. I'm here hiring developers. So if you are a Python developer, if you are interested in data, come and talk to me. Also, come and find me for questions. Thank you very much. That's it for me. I'm sure do we have time for questions? No time for questions, so find me outside. Sorry for taking so long, but enjoy your lunch. Thanks for coming out, guys.